Your Captain Ben has been involved in the final stages of the construction of this very special sailing cargo vessel. I've been mostly involved in the hybrid propulsion system, so mostly high capacity electronics. But I've also been part of the rigging team, and in this video I want to focus on that, the standing rigging. Especially, how do we put the tension on the rigging, the right tension. If you get the chance to sail on Juranai, of course you have to learn about the naming of the decks. Starting at the bow, that's where we see the foredeck. That is also where the crew cabins are. Then midships we see the main deck. That is basically the most upper watertight deck that runs around the two cargo hatches. Then further aft we see the poop deck. We talked about that in the video. What does it mean to be pooped as a sailor? Then the upper deck, that's also more forward the navigation deck where the bridge lives. And the highest deck on top of the wheelhouse is called Monkey Island. So what about the sail configuration? The sail plan on Juranai, starting at the bow. First we see the jib, a triangular sail. Then the foresail, a totally rectangular sail, same as the mainsail, further aft. And finally, what we call the mizzen, another triangular sail. All these sails are furling sails. Later, more about that. The sails are rigged up between two horizontal spars called the boom and the gaff. They are held up by kickers. The two rectangular sails, the foresail and the mainsail, are furling sails. And what you want to learn on board is the names of the parts of these sails. For example, the forward part is called the luff. On the back you see the leech. The top is also called the head, and the foot is the lowest part of the sail. All the sails are furling. That means that the sailcloth is wrapped around the furling pipe on the front edge of the sail. You can set the sail by tightening up the outhole and stretching the sailcloth aft. But let's start talking about the rigging, the standing rigging that keeps the masts upright. And let me introduce you the rigging team. This, of course, is your truly Captain Ben. Who else do we have? Underneath the bowsprit, Captain Evie. On top there's our rigger Ben. And also Captain Chrissy. Here we are visiting Busan, and on the right you see Taitera, our Kiribati friend. This is the mastermind, Captain Evie. Coming down from aloft is Carson. And Taitera following suit. Right, the purpose of standing rigging is to keep the masts upright and to deal with all the forces in the sails. So all the fore and aft running steel wires we call stays. Starting at the bow, we see the forestay, then on top the upper stay or triadic stay, and then of course the aft stays. The steel wire ropes running athwartships the ship, they will stop the mast from toppling over to port or starboard. They are called the shrouds. The steel wire rope that's attached to the top of the mast is called the cap shroud or upper shroud. Then we have the lower shroud underneath and the spreader basically holding the cap shroud to the side to create less of an acute angle. For our running rigging on Tjuren I, we use braided line. And this is Captain Chrissy explaining to our bosun Teterra how to splice an eye in this special type of line. It's a great skill to learn and it's got beautiful results, as you can see. Okay, let's get ready for the standing rigging. Here we go. Tooling a steel wire rope in the rigging is basically the same as tuning the string on a guitar. The higher the tension in the string, the higher the frequency, so the higher the tone. For measuring the tension in the rigging, we use this app called Fivox. It's a great tool to have that makes it more easy to count the vibrations in the wire while we shake it. As you can see here, I'm shaking the wire and taking the recordings by putting my iPhone against the wire. Then you can see the results in a graph. These are the results of gauging the frequency for 15 seconds. And we can now relate the frequency to the tension in the wires. That's gonna be logged in this sheet here. We do several measurements until we reach the final tension. And boy, let me tell you, tensioning up those big turnbuckles is a hard job. It's great to have Kiribati power on board.
One, two, go.
No, knuckle whip.
No, whoop.
What?
No, whoop.
Ah, that's it.
It's too tight.
By finishing the job of tensioning the standing rigging, we make sure that Tjuren I can handle the wind forces for our delivery voyage. So, see you soon!